We are going to talk about focusing on your code and not your infrastructure. There have been other talks about setting up your servers and how you're supposed to configure them. And we heard in the previous talk about you shouldn't host your own database server. So as developers, we want to focus on our code, our business logic, and not about how many servers we have and how much RAM there is and what version of Linux we're running on them. Let's see, there we go. So before we, there we go. First, this is what I look like when I wear a denim jacket. My name is Martin Omander, and I was born and raised in Sweden. I've lived in Silicon Valley for these last 19 years. I've been working at 3 startups as a software engineer before joining Google. And then I've been at Google for these last almost 13 years. And my job at Google is developer advocate. So just like you heard in the intro, developer advocate, that means I have 2 jobs in that position. One is to tell you guys about Google Cloud products that you might use for your projects. And the other job I have is to listen to you and hear about your feedback on Google products, so that then I can bring it back to the product managers back in Mountain View, California, and they can build better versions of these products. So I'd love to hear from you, and there will be a survey at the end as well, so if you used any of the products I'm talking about here, I would love to hear from you what your impressions were and what we could improve in them. Okay, so we're going to follow along a story here today with a fictional startup. And as they go through and build out their MVP and the minimum viable product, and how they eventually build out their system to scale better and to do more things. And the startup we're going to talk about is founded by Beth. She likes jokes and she likes spreading joy to the world. So she has this idea of her startup is going to be called Jest. And it will have something to do with spreading jokes out there in the world, getting people to laugh, spreading joy. And always when you design an app, you should think about who the persona of the user is. So Beth, she is thinking of Alice. Alice will be a typical user of Beth's service. Alice is on her phone all the time, and Alice should be able to follow along a very simple use case, which is Alice should be able to send a text message to Beth's startup, and then Beth's startup will turn around and send a joke back in the text message to Alice. Super simple use case, right? And this will hopefully get millions, if not billions of users, and Beth will spread lots of joy in the world. Now, if Beth sits down and does a Google search on, scalable web-based systems or highly available computing or fault-tolerant computing, she wants all her service to be all of those things, of course. When she searches for that online, she might come along graphs kind of like this. This is the infrastructure behind Wikipedia. And there's something like 27 boxes in here. There are databases, there are servers, there are caches, there are load balancers, all kinds of other boxes in here that somebody has to set up, understand how they work, set up, configure, and maintain. Now, Wikipedia, they're using this, and their system is obviously highly available. It's not often we go to Wikipedia and it's down, right? But Beth is running a startup. She doesn't have time for all this. If, let's say, it would take 2 weeks to set up each box in this graph, that would mean it would take more than a year to just build out the infrastructure, even before she's even written a single line of code, business logic code. So what Beth needs is something that's as highly available, as fault-tolerant as this, but will allow her to get to market far sooner. And if you're developers and writing services for your companies, you probably want something that's simpler than this as well. As highly available as this, but simpler. So what Beth really wants is 2 boxes instead of 27. So we have Alice out there on the left. She would send a text message. Twilio would take that. Twilio is an SMS gateway. They basically translate between incoming SMS and HTTP. Has anybody here used Twilio? 1, 2, 3, 4. Oh, cool. 5? Oh, excellent. How do you like it? Did it work well for you? Yeah, it does its job. Yeah. Twilio is not affiliated with Google in any way. I just use it because it's an awesome service. So anyway, the text message would come in from Alice. Twilio would translate it to an HTTP call. Beth's microservice there would take the HTTP call, return a joke, and that joke will be sent out to Alice. And then, of course, Beth, she would write the code, and she would deploy content, deploy jokes to the microservice. So 2 boxes instead of 27. Now the question is, how can she still get something that's highly available and always up and is highly scalable when she doesn't do the 27-box method? Well, what she can do is Cloud Functions. And we're going to dive into that. Google Cloud Functions are built specifically for these microservices, where you have some business logic and you are content, you're fine with giving it to Google and letting Google figure out how many machines it should run on, let Google figure out where in the world it should run, all that stuff. So let's see what the code would look like for this microservice. Now, Cloud Functions can deal with Python or JavaScript or Go. Beth writes, she likes JavaScript. So her index.js, there's only one file she needs to deploy. And her index.js would start here. She would import some Twilio libraries. And then she declares the reply function. Has anybody here used Node? Node, a few, half? Okay, cool. So this, you might recognize this as, this is one way you can, in Node, say, here's a function reply, and expose that to code outside this file. So then Beth would take the request. She would create a message response, an SMS response. She would then put the joke, called getJoke, put the resulting joke inside the SMS response. And she would return the SMS response in XML format. Why XML format? Well, that's the way Twilio likes it. So return it back to Twilio in XML format. Twilio will then unpack that XML and send the SMS back with the joke to the user. So this is a lot simpler than 27 boxes. This is one file, and she deploys this, and her microservice is up and running. Except there's one thing missing here. What would happen if she only deploys this? Can anybody see what I've left out? getJoke, excellent, well done. Your name? Josh, excellent, Josh. So yeah, you see here that she calls the function getJoke. getJoke must be declared somewhere. Now, I hesitate to show the getJoke function because it's not really elegant code. I'm not going to say I'm proud of this code. I'm going to show it. Please don't judge me. Okay, here it comes. First line. We open up a square bracket. Does anybody see where this is going? Yes, here we have a joke. Here's another joke. Here's a third joke. That's it for our jokes today. All right, great. So we have a hard-coded array. Remember, this is a startup. They're doing the MVP, the minimum viable product. It doesn't have to be fancy. It doesn't have to win any code contests for elegant code. And then we have getJoke, of course. getJoke would just generate a random number and then return the joke that's on that position in the array. So this is great. It allows, this also goes into index.js, by the way. So through, what's this, like 15 lines of code or so? She actually has a service up and running that can respond to SMS messages and that she can show off to investors. It only contains 3 jokes, but maybe that can be expanded on in the future. And that's actually what the investors say. When they see this, they are amazed. Like, you can send text messages, we get jokes back, it's amazing. Here's a lot of money. Go and build a better version of this. And your first job, they tell Beth, your first job is, we love your 3 jokes you have in the service, but you actually need more than 3 to make it a service that people will want to use. Okay, Beth, she's fine with that. She goes and hires Charles. Charles is a writer. So she hires him as content manager here. He is great at coming up with jokes. So Charles, he gets the desk next to Beth. He sits there and he writes and he sits there and chuckles by himself. And then he's like, oh, Beth, I have this excellent joke. Can we put this in here? And Beth is like, okay. She dutifully opens up index.js. She adds another entry in the hard-coded array we just saw. She deploys it. Very good. 5 minutes later, Charles comes, tells her, like, oh, I came up with another joke. Could we put that in? It's a joke about Belgians. She uploads it, everything's good. 5 minutes later, he's like, oh, I just got a bunch of angry emails from people in Belgium. They really think that is an offensive joke. Can you take that joke down? She again opens up index.js in a text editor, removes that entry. Now this is a problem. Beth, who is the developer, she's in the content deployment loop here. It's fine for her to be in the loop of deploying code and new functionality, but not for deploying content. How can she take herself out of the loop? Well, she can build an admin user interface. That would be cool. And she starts thinking about she can use Angular or React or Vue or something like that and build a web application that Charles can use, where he can add and edit, delete jokes. But that's a significant amount of work. It's a lot more work than those 15 lines of code that she built the whole service with, 15 lines. And if she's going to build an admin interface, that's going to be hundreds of lines. And then she realizes there is one admin interface out there already that she can use. It looks like this. It's a Google spreadsheet. This one, with a Google spreadsheet, you can add stuff, you can remove stuff, you can edit stuff. By the way, my favorite joke here is number 10. What's good about Switzerland? I don't know, but the flag is a big plus. You chuckle politely, and I appreciate it. My daughter tells me that those are terrible dad jokes. You're not allowed to show them to people. And then I tell her that I show them anyway, and she's like, Dad! But, so with this, now Charles, he can just deploy, he works off that spreadsheet, right? And then the service, microservice, instead of reading from the hard-coded JavaScript array, it will now use the Google Spreadsheets API and read spreadsheet cells instead. Let's see what the code would look like. So here we have a little more code. You can already see it's a smaller font. We need to import some Google APIs. By doing that, we get the all of Google's APIs you can reach from JavaScript. Okay, getJoke, that one is now an asynchronous function because it's going to do some asynchronous stuff. Calling the reading from a spreadsheet is an asynchronous operation. Okay, so first off, authorization becomes super simple when we run up in the cloud, because you notice here there are no passwords, no keys, no OAuth nonsense going on here, because with the in your cloud account has your cloud project has a service account in it that looks a little bit like an email address. You can copy that email and paste it into the spreadsheet. Say, in the spreadsheet, give access to this email address, just like you would give access to, a Gmail address or something else. And then this project, all the code in this project can now read from the spreadsheet. Okay, then we just need to say that we're using version 4 of this API. We will call the Spreadsheets API. What parameters do we need when we call the Spreadsheets API, do you think? Any guesses? Sorry? Column A, what column? Yep, exactly. What area of the spreadsheet to read? Yeah. On what sheet? Oh, wow. Have you studied ahead? This is excellent. You used Spreadsheets API before? Oh, good, good. Does it work well for you? Was it hard, easy? Oh, config stuff. Oh, I like that. That's cool. Yeah. Excellent answers, both of you. So yes, we need to say what spreadsheet ID is it. If you open up a spreadsheet, you will see this in the address bar of your browser. And or then what area of the spreadsheet to read, what cells. This is shorthand notation for saying sheet 1, all of column A. Then we get back a response. Now that response will be a two-dimensional array. We don't want a two-dimensional array, we want a one-dimensional array. So here's a bit of JavaScript trickery to sort of boil that down to one-dimensional array with arrow functions. You might use a for loop here if you prefer that. Anyway, now we have a one-dimensional array called jokes, which is great because now we can revisit our old friend here, index, we get a random index, and we return the joke at that address. So the code is a little longer, but on the other hand, now there is the admin interface, and Beth is not involved in deploying jokes and removing offensive jokes about people from Belgium. That is Charles' job completely. Now this is great, and Charles, he is amazing. He is very good at what he does. He adds hundreds of jokes. He adds thousands of jokes. And he adds, maybe looks up and copies from the internet, tens of thousands of jokes into this spreadsheet. Everything had worked well until now, and now we're seeing some growing pains here for the startup. Any guess what might be causing problems at this point? Yeah, speed of querying, yes, exactly. So what happens is that sometimes that reading from the spreadsheet becomes a little slow. And you saw the code a minute ago. It's actually not that strange that it becomes slow because let's say there are 10,000 rows in the spreadsheet. The code goes in, reads all 10,000 jokes, picks one random joke, returns that to the user, and throws away the other 9,999 jokes. It does that every time somebody requests a joke. So not the most efficient code. It's great code for getting something quickly up and running, right, for a startup. And that's what you should never over-engineer gold plate your solutions. You should build something that works just barely well enough. But with success and more traffic, you need to have something more scalable than just a spreadsheet here. What might be a good place to put here instead of a spreadsheet on the back end of the microservice? Database, yes, very good, very good. We heard about a lot of databases before the previous talk, NoSQL databases, SQL databases. Beth is most familiar with SQL, so she picks Cloud SQL. This is Google's hosted SQL. It speaks MySQL dialect or Postgres, whichever you're most comfortable with. So then there would just be, it would read over a socket here, and then she writes an export job from the spreadsheet that every now and then puts all the jokes from the spreadsheet into the database. So Charles can still work on his spreadsheet that he's familiar with. Let's look at what the code in the microservice would look like now. We would a function get joke, all right. Here's SQL for the end of this SQL, order by rand, limit 1. That is basically a very fancy way and very efficient way of saying, give me a random row from this table. And it's super fast. And I did not invent it. I copied this from Stack Overflow, just like you do with your code. But it's great code. And then you just, we need to do some stuff with, it's asynchronous, and we need to do promises and things like that. Get a new connection from the database pool, run the SQL, return the result, and we're done. So actually the code became even a little smaller after reading from Cloud SQL here. And now this has gone from maybe taking half a second to do down to take more like 70 or 80 milliseconds to read a random joke. All right, so things are going very well. We now have, Beth now has a content manager who has a nice admin interface, a very scalable data solution up here, very fast, everything's going well. Now the investors tell Beth, look, you need to optimize your service. You need to find out when during the day do the users use your service. Who are the most active users? Who are the least active users? Maybe we can reactivate them. What jokes do people request? So she hires Daphne, a data analyst. Daphne goes to Charles and asks him these questions about like, when are users most active? Who are the most active users? Charles, he looks in his spreadsheet and he says, well, I don't know. I manage a spreadsheet of jokes. So Daphne goes to Beth and says, look, we need to add something to your microservice that you've written, that nice little thing of 15 lines of data, of 15 lines of code. You need to add something there that logs all the visits in an analytics database so that I can then run reports on it. Now, Beth becomes a little concerned here. Because you know how it is, right? You've written this nice piece of tight code. It's very short. It's easy to understand. It's not, you know there are no bugs in it. And then somebody asks you to just add one little thing. And then another business owner comes in and says, just add this other little feature. And then somebody says, oh, just if this, then that should be in there somewhere. And all of a sudden you have this 1,000-line monster that nobody wants to touch. Beth wants to stop that early on. She also wants to have this microservice always work, even if the analytics database is down. Even if Daphne changes some names of columns and tables in the analytics database, that shouldn't result in an error here that then means that Alice doesn't get her joke. So also she wants not to write the code for this herself. She wants Daphne to write this code. So often when you have multiple teams working on multiple facets of a system, you don't want to tie them very closely to each other because then you have a system that is brittle and a system where you have to understand everything that's going on. And all teams have to talk with all other teams all the time. There is a way to disconnect parts of a system to make them more resilient and to make your development teams being able to work more independently. And that is you can add an asynchronous message bus between them. So what Beth would do in her microservice would simply be to add just a little snippet of code that sends out a message on the bus that says, hey, a joke was requested. Very little code. Then Daphne will write a function here that listens for that message. And whenever that message comes around, Daphne's code will then do whatever needs to be done. In this case, insert a row in the BigQuery database, in the analytics database. What's cool with this is not only can they work independently, but also when a new team comes on, I don't know, legal team, PR team, marketing team, all kinds of other teams, they could have their own teams up here writing code and listen to messages that go out on the bus without the actual microservice here having to be modified. So let's look at the code for that. So this is the reply function, get joke, we call that, and this is a synchronous function. Here, this is new code, publish pub sub message. The messages are going out over a bus called, the bus in cloud, the Google Cloud Platform is called pub sub. So publish a pub sub message, and then it's the same code, read this as you've seen this before. Publish pub sub message, let's look at the code for that. That is what actually creates a message and puts it out on the bus for others to consume. So publish pub sub message, you would put together your data package that needs to go out. What data? So the record basically that needs to go out on the bus. Then you create a pub sub instance. You package up the data we just had before, like what joke, what phone number, when it was requested. and then we publish it on the bus with this publisher.publish. Also, we have a joke sent here. That is the topic. So a topic is basically so that Daphne's code on the other end. Daphne would write, I want to listen to the topic called joke sent. Okay, so that's the only difference, the only addition that Beth needs to make to her code. Now let's look at the code that Daphne needs to write up here to intercept this message and write to the analytics database. So she would get the payload, extract the data from the payload. This is sort of boilerplate you would do always. Then she would create her own row that she wants to insert in the BigQuery database. She would instantiate, if you have created a BigQuery object, and then with that she can say, in this data set, in this table, insert this row. And she's done. So now we actually have a pretty nice system here with, we have users coming in, the microservice is running here that's really fast, that connects with a really scalable data backend. The data backend is fed by an admin interface that a content administrator is using. Also, everything that happens is logged and goes into the analytics database in an asynchronous fashion, so it doesn't slow down the regular system. And bugs in the code up here will not affect the microservice, the user-facing microservice. This is actually a pretty sophisticated system. And the best part of it is less than 100 lines of code. This is the power of stuff you can do with serverless computing. Nobody here needed to think about servers. Let's see what it would cost. I made some assumptions here. Cloud SQL would cost between $8 and $55 per month, depending on SLA and CPU and things like that. It would be cheaper, considerably cheaper, if you use NoSQL, because that, as we heard in the previous talk, that scales far better. So it'd be more like $0 to $6. You would, of course, pay for Twilio SMS messages. Do you remember what they cost? Or did anybody who's used Twilio remember what they cost? Yeah, something, yeah, I forget also. And also I don't work for Twilio, so I should probably not quote their pricing. Beth would go and negotiate with them. All right, so let's say she has 100 requests. No, let's say she has 100,000 requests per month. How much would she pay beyond the database and such, just to process the code we saw here? Any guesses? What's that? Zero. Good. Yes, that's right. Up to 100,000 would be free. Okay, let's say 1 million requests in a month. How much would she pay? $10 maybe? She would actually pay $0 for that as well. So this is, and then we can see the costs increase here. If she get 2 million, she would pay like $2. Up to 10 million, she would pay something like $23 or something like that. Serverless computing is really cost effective for some things, like the stuff we just saw. Because you're not running a server, you don't have to have somebody there who manages the server. The server doesn't have to be on all the time. When this is not used in the middle of the night, Google can shift, uninstall it, whatever, so that you're not paying, you don't have to pay for a server being ready all the time. And when your service is called, only then do you pay. Very cost-effective way of doing business. People are using serverless computing and cloud functions for other things than just sending jokes by SMS. We have serverless backends for IoT. That is one common use case. Data transformation, real-time data processing. CNN, Turner, they own CNN.com. They use a lot of cloud functions for moving logs around between their machines. Also, we've seen, if you've gone to any of the assistant talks here, when this Cloud Functions is a great match for assistant, because it is the user says something, that goes into the function does its processing and returns something. That's a very natural fit, assistant and Cloud Functions. Very good. Now, we are going to do, well, you are going to do 3 things at the same time. They're all voluntary. The first one is, I would love to hear your feedback on this talk. And if you fill out the survey in about 10 minutes' time, we will have a drawing. And one lucky person who filled out the survey will get a Google Home that they can write applications for or use at home. That is this URL. Please go here and fill out the form. Everybody, I would love for you to do it. Second thing, you are dying to hear more bad dad jokes, I'm sure, and want to see that the code actually is running. So if you feel like, send a text message to this. It doesn't matter what text you send in the text message. You saw the code just throws away whatever you write. But you will get, well, if the system is still working, you will get a joke back. Those were 2 things. The third thing that we are going to do is I will answer any questions you might have. And the first 4 people who ask questions, and there's the very first one, the first 4 will get a Google pen that glows in the dark when you press here. And it's not only a pen, the back end here is you can use as a stylus for your touchscreen device. And we have 1 pen going to, yes?
Question about
microphone.
When using Firebase functions, it seems that it's basically just a Google Cloud function because you're kind of using the Google Cloud platform. Firebase is built on top of it. So are all of these things also available when deploying Firebase functions? Do you know?
Yeah, Firebase functions versus...
Thing that you were showing there?
Yep. Good question. So here it says Google Cloud Functions. There's also Firebase functions. And it's the same backend. You just use 2 different tools to deploy with. If you use a lot of other cloud stuff, Google Cloud stuff, you will want to deploy with a G-Cloud tool. Then it's called Google Cloud Functions. If you use a lot of Firebase stuff, you are probably more familiar with a Firebase deployment tool and then use that. But it's the same thing. Yeah. 3 more pens for people who ask questions. Any other questions? Yes. Travis, yellow pen for you.
Google Cloud for what other kind of things could you use the Google Cloud for smart devices? Like
Google Cloud for what devices?
Smart devices, like like the Google Home.
Yeah, yep, definitely.
Besides the functions, what else would you?
Most applications that people have written for Google Home use cloud functions. Smart devices, IoT, Internet of Things, people use it because there you don't want to have a server, maintain a server that is always up. That is really hard to have a server be up 100% of the time. But writing a cloud function and trusting Google to be up 100% of the time, perfectly doable. Yeah.
So this might be a stupid question. How do you integrate cloud?
You'll get a pen anyway.
I always make a disclaimer that this might be a stupid question. That way no one gets mad at me for being
I love
asking a stupid question. Anyways, how do you integrate cloud functions with Firebase?
How would you integrate cloud functions with Firebase? You would, what part of Firebase? Like reading from the Firebase database?
Yeah, like a real-time Firebase,
Yep.
Firetime.
Yeah. Real-time database?
Real-time database,
Yep,
yeah.
yep.
How would you integrate it with that?
Yeah, so you would probably deploy with a Firebase deployment tool, and then it's called Firebase Cloud Functions. Mm-hmm. And you basically write event handlers for like, if something changes in my database, then run this code.
Okay, so it's like its own version of Cloud Functions that's not related to this, sort of? Is that?
It is related to this,
Okay.
yeah. But you do get, it becomes a little easier. You get more functions and libraries for reading and writing Firebase databases. So it becomes a little easier if you deploy with a Firebase tool.
How does that compare with just writing on a Google Cloud service provider? Like, how does that compare in terms of functionality versus the Firebase?
Yeah,
you said it's easier, but like in terms of functionality, is there any difference?
It's one makes it a little easier to integrate with all of Firebase.
Mm-hmm.
offerings, and one makes it a little easier to integrate with all of the rest of Google Cloud. You can do both with both, but one is, if you're using Firebase and familiar with that, use Firebase Cloud Functions. If you use Google Cloud and use the G-Cloud tool, then you use that.
Okay, so you could just stick purely Firebase and just call it a day, and you can get the same
Yep.
features. Okay.
Yep.
That's
Yeah, blue pen for you, sir.
So when you're making the index.js there, and you're wanting to use third-party libraries and things like that, is that just an npm node module install there, or are those available? Is there a list of what's available in the docs or something?
Yeah, a few things are available already, but the typical way you do is npm install. And then Google understands package.json and all of that stuff. So then so basically when you deploy, what really happens behind the scenes is that package.json, all that stuff is zipped up and sent to Google, and then Google unpacks it and installs it. So npm install will do it. All right, have you filled out bit.ly/cloudfunk? I hope you have, because we're going to do the drawing for who gets the Google Home device. Let's hop over to the wheel here. Let's see. Okay, we have a few in there. Very good. We'll just import here. This is an application I wrote just to use that in my own presentations. And there were tons of bugs in it. Yeah, sometimes this happens. But then I start getting these messages from teachers. Apparently, lots of people are using it. According to Google Analytics, I have 6,000 users per day. So maybe I should fix the bugs in here. All right, here we go. Form responses, first name. All right, there you are. Are you on the wheel? Do you see your name? If not, this is your last chance to fill out bit.ly/cloudfunk. All right, the way this wheel works is it's powered by drum rolls. So you're all at table, or you all have legs. We're gonna need a drum roll. Okay, let's hear it. Ooh, who's gonna win? Oh, Patrick! Yay! Here you go, Patrick. Do you have one of these already?
I do, but this
You
is
do?
great.
Oh, an extra one. Very good. Thank you very much for your attention. I'll be around if you have any questions. Thanks for coming.